guess it doesn't matter. Storage is cheap.
5-gallon head and a 10-gallon hat. Hello and welcome to the Hackaday Podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 357, BreezyBox, Antique Tech, and Defusing Killer Robots. This week in Hackaday News, boy, this is an Al Williams title if I've ever seen one. Forget Waldo, where's Luna 9? A write-up of the attempt to find 1966 Soviet moon probe Luna 9, which actually was the first spacecraft to soft land on the moon. It is so lovely looking. I want you to put down your podcast and go look at this thing over on Hackaday. It is that like creamy beige boxy 1960s Soviet style, and it's got this giant inflatable football for a nose because this thing did a soft landing courtesy of this big balloon nose. Oh, and the news bit is that they have finally...
Okay, where are we going with this?
So lost in this crazy moon probe. The news...
This is what the future was supposed to look like, right? Like, this is what they took from us.
Yeah, it is.
It is very, like, vision of the future, you know, in the year 2000. Everyone will have one of these in their backyard.
It's got round chromey bits. It's got... Yeah, but it's also... There's just something about that, like, 70s era... Soviet mechanical aesthetic that just speaks to me. I don't know. It's pretty funny. No, the point is that they have recently released its coordinates and people are looking for it. Lunar Reconnaissance Orbiter couldn't find it yet, but there's a chance that the Indian orbiter, Chandrayaan, is going to be looking for it too. We'll see who finds it first. Anyway, it's pretty funny. We were talking last week about... Was it last week? Oh, no, it was a few weeks ago now that we were talking about going up and returning some of the old satellites that are up there, like Telstar's still up in space or something. You go up there and fetch it, bring it back down to Earth, put it in a museum.
I mean, this one will be a lot easier to catch, right? It's not moving. Well, I mean, I guess it's moving in the solar system sense of moving, but it's on solid ground at least.
Right? Yeah, when we get people up there, they can go take a look.
It'll be a tourist attraction.
This way to Luna 9.
But no, it is a really cool story, and the Indian orbiter, I think they say next month, is supposed to, pass over the suspected, or one of the suspected landing areas, and it has, I believe, the highest resolution camera of anything in orbit around the moon currently. And even then, they were saying, like, it'll be maybe 2 pixels. I mean, it's still very small. It's, like, way smaller than, any of the other stuff, which is kind of impressive because, I mean, they've been able to take pictures of, the tracks from the lunar buggies and stuff. So even smaller than that, right?
There's a lot of surplus gear up there on the moon now that you mention it. Speaking of the lunar buggies.
Yeah, right? All kinds of stuff. Someone's going to make some bank when they...
Dude.
When they get up there and, put some fresh batteries in there and you can sell tickets for rides on the... but to pretend you're one of the Apollo guys. I think that's why we have to have like some kind of heritage thing on the moon. Maybe they have that already. I think there might be some international norms for that kind of thing.
Keep cheesy people from joyriding around in the like Apollo 15 lander or what?
Yeah, right. And when they left it there, they're like, it'll be safe. You know how it is. You park your car somewhere and you think it'll be fine.
Wait, where did I leave it again?
Yeah. And 70 years later, some Yahoo billionaire is riding around in it.
Well, speaking of space, let's do a What's That Sound?
Oh no, it's a What's That Sound?
but I gave you a good clue, man.
Okay. At least I'm starting with something.
This is a journey into sound.
What's that sound?
What's that sound?
This week is a Guess the Sound week. That means we have a brand new sound for Tom and you at home to guess at.
The introduction starts like this. Space, it says, is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is.
Oh! Yes, finally.
You got it in one.
I will be upset if anybody does not get it. That is very, very apt.
Yeah, my wife suggested this one, and I went back and I was looking through, and I'm like, oh, so good. It's too easy. I'm going to put it in anyway. It's too good not to. So sometimes what's that sound is, meant to be a stumper, some obscure mechanical mechanism that makes its noise. And sometimes I just want you guys to go out there and remind yourselves of something.
Yeah, if you didn't know it, then you should definitely put aside some time and
if you don't know what the sound is, this is your lucky day.
Oh, that's a good way to look at it, right? You get to experience something for the first time.
Next week, you are going to have a good time. So if you do know what the sound is, and you might just head on over to the podcast landing page, hackaday.com/podcast. Scroll down to what's that sound, enter your handle and your guess, and we will roll among the correct answers next week for a Hackaday Podcast t-shirt. Yeah.
So you have to break out the big die.
And quick teaser, we are hoping to get an announce out next week. It looks like Hackaday Europe is going to be in May, and it may be in Milano. Stay tuned next week to Hackaday for more details once we get everything fully hammered down. All right, well, I wanted to start the hacks this week with a very Hackaday hack. This is BreezyBox, a BusyBox-like shell and virtual terminal for the ESP32. Project by Valentin Danilchuk, and it is multi-layered and absolutely fantastic. If you're programming on a small microcontroller, it's not half as friendly as programming on your big computer, right? Because, you don't have a terminal window. You can't just type into it and experiment around. You can't save files. It's all this like compiling and flashing, and that's no fun. If only there were a way to run a terminal shell on your microcontroller, in this case, an ESP32. So BreezyBox gets you a shell on your microcontroller, and it does, the simple file system like things, virtual terminals, but also some fancy stuff like ANSI colors. So you can do graphics, which he's got a great demo of. Color text graphics, odd blend of the modern and the old school, but tab completion, thank you very much. History, it's got all the stuff that you need to be productive because the ESP32 has Wi-Fi, it has Wi-Fi commands, it's got an HTTP server built in, et cetera, et cetera. But the real point here is, of course, is that it's interactive. And that's what is the best thing about shells is you can screw around and play with things. And here, because the system is in C, you can compile stuff. And because it runs on top of the free RTOS, which is all part of the Espressiv's ESP IDF, which is something development framework. It's multitasking and all that mess too. So it's actually like a shell running on top of the computer that is secretly your ESP32. We've been doing the badges for SuperCon in MicroPython for the last little while for exactly this reason too. Right? Like it's nice to have an interactive shell that you can program with and poke around with. I actually haven't tested it out yet. I 100% want to.
As cool as the, user experience looks, right? Like I said, the interactive nature of it. Like going through the GitHub, it is an engineering marvel too. Like that's like equally as cool as how well, it's all documented and implemented. It talks about like the quick start. Like you might be expecting this to be some kind of like, binary that you just flash to your ESP in sort of the style of like, MicroPython, right? Where you have this like ready to run image. But it shows here where you could just pull in breezybox.h into your code and bring the OS into whatever you're working on. So it's made to be, extended. And there's even an example with like, how you can add new console commands. Remarkably simple to just, implement your own like kind of macro things in this environment. Like you were saying, you can pull in new precompiled apps, which is really cool and has incredible potential there, right? For loading new capabilities and stuff that's already in the field without having to reflash the firmware. It is really, really cool. I'm really digging this. Like I was saying before we recorded, I must have missed this one when it went out. So I'm kind of seeing this for the first time. This is my real-time response to this project, and it is phenomenal.
Hackers discover BreezyBox.
Yeah, right? And then there's also a separate GitHub repo with all applications, and he kind of invites you to say, here's the, the boilerplate for making your own little apps that you can pull in. So that's really cool. And, he's provided, a handful of demo ones, but he's looking for contributions from the community. So, I mean, even if you're not into the low level thing of, working on the BreezyBox side of it, maybe you could just, contribute apps or, whatever your project is, you could, put your little version up there. I think that's really cool. Perhaps the most impressive part of the BreezyBox apps, though, is that they're all POSIX, and you can actually build them on Linux and run them. And I am actually running one of the apps.
Oh, no way.
Right now on my Linux computer. I'm like, my mind is blown that you could run and do all your like prototyping and stuff on your Mac or Linux, or I think even Windows these days can do it natively, right, with the subsystem. So you could have the code running on your computer and say, okay, that works, and then just cross compile it for the ESP and send it over. Like, that is really, really cool.
About the apps for it, the Breezy apps collection, I was like, oh, this is great. A terminal is fantastic. What's the first thing you need, though, to actually be productive? The answer is an editor. And so I'm going through there, and lo and behold, VI. He's got it. It's there, ready to go. You could just import it. And like what you were saying about how easy it is to add these sort of things to your project is totally true. I'm a huge fan of the kind of tooling around the ESP IDF. It's made a lot of things really simple. They're basically just a bunch of Python scripts running over make, but they make things really simple, and they've got some nice menus. It's a sweet little system, actually. You can also sidestep it and go low level if you want to. But here in this case, he's got it set up using their component registry system. So like Tom said, you just have to say add dependency BreezyBox and then put the include file in there, and you are off to the races. So super easy way to throw a little console into your application in case you need it. And you probably do. You always need a console. Like, who are we kidding?
This is super cool. Man. I'm just lost in this thing. We might have to revisit this. I think this would be very cool to do. Somebody like kick the tires and really mess around with some of these features. Am I understanding this correctly? That he has a mini C compiler that runs on the ESP32, so you can edit and compile code on the ESP32.
Yes.
Wow. This is like Inception.
You've got VI,
right?
You can write files, and then you can compile it and then run it.
And he even says in the notes that the compiler can compile itself. Man,
you can launch the application you just wrote on the ESP32. You can launch it on the ESP32.
Wow,
it's a damn computer, son.
Man, podcast over and the episode. I feel like we peaked too early on this one. This is awesome.
Tom's got to go now. He has a family emergency.
I got the ESP32 with my name on it right now. Well, my first pick this week comes from a place that I think a lot of us have probably ventured mentally occasionally. This is lessons learned after a headfirst dive into hardware manufacturing. And this is a really cool, like, firsthand account of, I won't say what went wrong, because ultimately it did get out there. But this is a Kickstarter for Brighter, which was supposed to be the world's brightest lamp, or it says like bring the sun into your house kind of deal. It went to $400,000 and, very successful. And then the challenge is, well, how do we make these lamps? And Simon, the guy who did it, had no prior experience in hardware, so that's fun. Said, okay, well, now that I've got this money, that's the easy part. How do I actually produce these things? And as I said, ultimately he did get these lamps done. You can buy them right now, I believe. But it was not easy going, and it started with, day one, the Kickstarter said, it's a 50,000 lumen lamp. Oh, it's 25 times brighter than any other lamp, yada, yada, yada. They end up testing the prototype, and it's like 39,000 lumens. So, like, right off the bat, they're like, okay, well, we got to redesign the thing because we didn't do what we promised. Not that 39,000 lumens isn't quite bright, but... Yeah. So they had to start with a redesign immediately, and they actually ended up getting beyond 60,000 lumens. So you get more than what you were promised. And then from there, it's, well, okay, well, how do we communicate to all the players, most of which overseas, as you can imagine? It needs a crazy heat sink that doesn't exist on the market, right? So we got to get that made, and we got to get the knobs made, and we got to do the electronics, obviously, and it needs to be assembled. And there's a lot of moving parts. And it seems like for every moving part, there was a wrench thrown into the works, from the design not being specified correctly to the die makers for the heat sink. Apparently the holes that were meant for like the pins to push out the thing somehow got into the design. So there's like these weird cylinders on the heat sink that weren't supposed to be there. Wires were too short and the clearances on the knobs weren't right, and it was just like all these tiny little things. He talks about a lot of lessons learned, but kind of the biggest takeaway is that you need to specify everything. You can't take anything for granted. You might assume that, the person looking at this information will know that A follows B follows C, but maybe not. And you need to really put it all out there with as much accuracy as you can muster, and then probably do 10% more than that just to make sure that nobody is having to guess. It's an excellent read because there are so many practical examples, but stuff like they never told the people on the assembly line like how much wire needed to hang out of the base. They put them all together, and then when customers started getting the lamps, there wasn't enough wire to actually pull up into the the column of the lamp and connect it. And it was a simple fix, but nobody told them, so they just kind of did whatever they felt like that day on the assembly line. So things like that, and it's kind of a wake up call because you do a Kickstarter or whatever, and you get the money, and then you're on easy street. But that's when the real work starts.
Oh dear.
And even in this case where he had a prototype and he thought he was in a pretty good standing, and we talked about this many times before, there's a huge difference between making one and making 10 and then making 10,000. So this is a really cool real world example of that. And it ends on a positive note. Like I said, it ultimately all worked out, and it seems like everybody's happy with the lamp, and he's got his dream project on the market. So it's not like this is a cautionary tale that says don't do it. It just says, make sure you have all your ducks in a row before you go down this path.
The prototype of one of them that you've made is one thing, but then, taking the step, holy cow. Good on him for persevering as well and being like, okay, we need to design for a lot more light. We need to change this and change that so that it can actually work that bright, because the easy way out would be to just change those numbers and be like,
Yeah.
Did I say 50,000 lumens? I really meant 39,000.
Yeah, that was a stretch goal. So sorry.
Yeah, exactly. It is kind of communication with the fabricators that saved his bacon here as well. Being able to convey exactly what it is you need made and all that is super, super important. And that's not a skill that I think you can have until you try it, or at least until you see someone else doing it. And that's one of those things when we have projects like this that kind of border on the small run products. When we see those on Hackaday, I always think it's really super useful for other people to just see how the process would go without having to design their own run of 500 or 1,000 things and then, fail and run into all these things. So seeing kind of worked examples of the whole manufacturing chain, I think is a very, very useful thing. And so I'm always stoked. In my mind, I'm thinking of Joey Castillo, who got custom LCDs made with the, like old school ones with the numbers, not the millions of little dots, and gave a talk at SuperCon about how he did it and what the whole procedure was. And again, it's surprisingly easy. It's just a matter of getting them, well-dimensioned PDFs and everything so that they know how to do it. But I don't know, going through all of these different steps and listing out all the things that the manufacturers are going to need to know to be able to manufacture it is super useful. So stoked to see this one.
Yeah, definitely having somebody go through and be that pioneer, I guess, for kind of a lack of a better word, is very helpful because, this is kind of industry black magic, right? That if you do this, if you're IKEA or whatever, And you
Right.
make
Yeah,
lamps
yeah.
all the time. You know these things, right? And nobody needs to tell you that because you've been doing it. But if you're just somebody and you're trying to break into this, and it kind of reminds me too of the keyboard on the SuperCon
Yeah,
badge.
exactly.
It's the same kind of deal. Like these little membrane keyboards are on all kinds of stuff. But if you would ask me, well, how do I get one made? I would have no idea. So now that kind of legwork has been done and documented, and there's guideposts, we'll potentially start seeing more of that in the community, and that benefits everybody.
Yeah, and actually that experience is exactly why we got Arturo to help us with it, because we had none. and he had plenty. So, it's great to see and great to push that info out there. My next hack is a Saving Stuff from the E-Waste hack by Tucker Osman, upcycling an iPad into a touchscreen display for your PC. And it's pretty funny. The money shot at the end, I'll just tell you, is a broken Microsoft Surface running Windows 11 displayed through a broken iPad with its display and touchscreen working. And that's the real hard part here. I don't know much about iPads, but apparently the third and fourth generation iPads are iCloud locked, which means they are apparently bricked on the second-hand market, and there's not much you can do with them, except you can pull the display off and drive it. And they use embedded DisplayPort, which is basically just DisplayPort on a different connector. So there are adapters that let you use this with any old DisplayPort computer. That part is solved. The part that wasn't solved is how to make the Apple touchscreen work. And that's the part that Tucker tackles here. This is a 20-minute long video. So basically 15 minutes of it is him talking about how he handles the touchscreen part. It's actually a really funny video if you're in the mood for just some kind of lighthearted goofiness mixed in with high-tech wizardry. This is actually a great video to watch. If that sort of thing puts you off and you just want the facts, you're with the grumpy people in the comments. Grr. What I really enjoyed about this is he goes through how he approached the problem and then how he solved it, and of course the problems along the way. But the basic idea was he had a working iPad here, and he knew that the kind of touchscreen pipeline was touchscreen into a decoder chip, into another decoder chip, and then over SPI into the CPU. And so he knew where to listen, and that is at that last stage SPI line to see what the whole pipeline was sending to the CPU. And then he kind of tried to work his way back and get more and more fundamentally into it. I think that's always a great approach when you're doing this kind of low-level reverse engineering, is if there are some signals you can listen to in a system that's known good and running, that can save you a lot of work. And in fact, here there was some initialization codes. The last chip in this chain here actually gets a little bit of firmware flash to it and then some initialization black magic. That makes it work. Without that, it doesn't. And he didn't know any of that stuff. So he just snooped on it and replayed it, which I thought was pretty clever. He hooked up a Pi Pico to the SPI lines, just recorded everything that was going through as the chip got initialized, played it back to it, and that actually worked. After, I guess, a small snafu with a reset line that he left floating, but it actually needed actively driving up or whatever. Like that sort of electrical stuff can really make you pull your hair out. But otherwise, it was actually just a simple sniff here and replay the whole init sequence back into the screen that made it work. The last bit is to turn this into something like that's a usable device, and that involves some super fine pitch soldering, Pi Pico as the USB interface, again, taking advantage of the programmable I/O pins for the fast stuff here. And I guess writing a 10-finger USB device descriptor, which if you've ever done device descriptors is no fun. And he complains about that for probably 3 minutes of this 20-minute video. But at the end of the day, he's turned this into both a screen and a touch screen, and it's all dead standard. Everything works on whatever computer you plug it into, which is pretty damn cool.
This is it's kind of a weird one for me because it's half a good example of being able to reuse hardware and half a bad example, like on
Okay.
one hand, and I don't imagine that like Apple intentionally did this, but like the fact that like the screens internally use embedded DisplayPort is awesome, right? Because it
Right.
means you could take them out and you could use them in other stuff. And I don't think that was like their intent. I'm sure they just did it because it was the path of least resistance, but that's great. Like you can get a DisplayPort controller, you can get one of these screens, you can hook it up. I'd love to see that on more stuff, more like common interfaces and protocols that let us take components out of something and reuse them. That's awesome. That's like that's the dream. On the other hand, the touch side of it is the opposite. The touch is the weirdly undocumented, proprietary for no reason nonsense that we have come to love and expect in most consumer devices, right? So this is like a bittersweet kind of story because the first half of it is like, wouldn't it be great if you could just take the screen out of your old phone or your old whatever and repurpose it, like, oh, here's a broken phone, but I could take the screen out and oh, lo and behold, it uses a common interface and I can just do that, right? That's amazing. If everything was built that way, I can't even imagine. So like I said, it's kind of like a bittersweet project because like it shows this utopian vision that we could have if it wasn't for the little details. All right, well, my next one is, I think, a really cool one. This is exploring homebrew for the Pokemon Mini, and if you didn't know what a Pokemon Mini is, well, neither did I. You're in good company. It's a handheld gaming system in sort of the vein of the Game Boy, but as the name implies, it's tiny and it's very Pokemon themed, but it does have cartridge-based games and it does have like the familiar controls of the Game Boy, and it actually came out the same year as the Game Boy Advance. So technologically, it was fairly behind the curve because it has a monochrome screen. It's only a 4 megahertz processor. Very wimpy compared to the Game Boy Advance, but it was a lot cheaper, right? This was kind of meant for its own little spin-off market of Pokemon-themed games. And I had never actually seen the thing. I looked at this whole, all the information. I was like, I don't think I've ever run across this, which is kind of surprising because I could tell you in early 2000, I was definitely trying to catch them all. So it's a little surprising that I never came across this kind of organically back in the day. So it's a cool look at a obscure device from, it is a real Nintendo device. It's not like some weird third-party thing. It's, proper branded. So it's not often you come across a Nintendo system that you hadn't heard about. So it's interesting in that regard. But it also turns out that there's a pretty active homebrew scene for this thing. And there's a lot of great documentation. There's a website that helpfully is called PokemonMini.net. And it has all kinds of news and updates. And there's little tiny flashcards for it, so you can run your own software. And there's tool chains. And it's a really cool little community that I had never seen before. And, like I said, the system is quite limited. It's 4 megahertz. It's a 96 by 64 monochrome display. You got 4 kilobytes of RAM, but it's enough to do little simple games and stuff. And there's an argument to be made, like we've seen many times. Some of the most creative stuff comes from working within a confined environment, right? So you're kind of forced to think out of the box when everything is on such a tiny scale. In this particular case, it shows how, you can kind of do a start to finish game demo. Most of them are done in C. This one, I believe, is actually in assembly for added excitement. So yeah, just really cool, just to see there's this whole community, right? And I suppose that there's an infinite number of tiny little weird communities that are waiting to be discovered, and it's always exciting to kind of come across one of them. The downside, of course, is I looked on eBay and these things go for like $250 to $300. So I don't know that I'll be joining this cool little community.
Unfortunate.
Yeah. But if I think it speaks to, like I said, these are relatively uncommon gadgets. But if you happen to have one collecting dust somewhere, it's time to pull it out because there's a lot of cool stuff to check out.
Which is, what a hella cool little playground. So my first instinct there was to be like, oh, we could just make one. That's what I always do when the thing doesn't exist. And Eastmakes suffers the same problem as well. He was looking for 14 segment LED displays, but not like the ones you can buy off the shelf. He wanted ones that were in RGB. And so he built, I think it's an art piece. It's one of these huge arrays of 14 segment displays, and it says funny things. Either an AI program to say spooky things, or it just happens to be saying spooky things in his demo. Anyway, he was thinking, why am I just doing this in monochrome green? Why not do this in full-on fancy RGB? But he couldn't find RGB 14 segment displays, and I think there's just no market for it except for crazy artists. So off he went to start making it. The first thing he did was to try to figure out how even to make this form factor work out, because these 14 segment displays, I mean, they're what? They're 1 inch by 3/4 of an inch wide or something. They're reasonably small, but they're not tiny. He wanted to fit the LED in each segment, basically. So he went to these like ultra small SK6805s, which are 1.5 millimeters on a side. So tiny, and is able to put one of those in each segment. Then the question of physical layout, he did the fantastic trick of take one of the existing 14 segs he's got and actually just put it on a scanner, scan it in, get everything right to scale, import that into, I guess he imported into Fusion, got the measurements off of that, and then imported it into KiCad and did the circuit layout. KiCad just got, apparently, a repeat layout function. So he made one of these 14 segment ones and then could like duplicate it across a whole panel. I thought that was a pretty cool use of a new tool. And then it's time to get these things produced. The aesthetics matter, so he wanted to try out a bunch of different possible diffusers, in particular PCB diffusers, because that's kind of the easy way out. And then he also experimented with making his own 2-color 3D printed ones. So there's a white diffuser layer and a black isolation layer around it. And if you've played around with these things, getting the diffusion right on an LED project makes the difference between having it look, just absolutely killer and having it look like it's just got a bunch of LEDs in it. There's too much bleed with all the LED ones. He actually had a really cool idea, which was to put a bunch of like mouse bites around the edges of the segments in the PCB so that it hopefully wouldn't bleed as much, through the fiberglass into the next segment. Quasi-successful, I would say. His 3D printed diffusers end up looking the best, and I think that's the conclusion he comes to as well. Do you need RGB 14 segment displays where each segment can have its own color? I'm not sure you do. Is it going to make a really fun display if you're doing like an art piece, which is, I think, exactly the application here? Of course it will.
Yeah, I don't need it, but I definitely want it.
You kind of want it.
This is one of those ones where like friends were sending me the link to this like unsolicited. Like have you seen what this guy did? Incidentally, like anyone who's listening, please send me more links of cool stuff that people are doing, because that makes our day-to-day a lot easier. But yeah, it is a fantastic project. It reminds me a lot of like the badge life kind of stuff. I could definitely see somebody doing this on a badge or like an SAO or something. There's a lot of similar tricks here, shining the light through the FR4 and stuff, which is something I've played with, and like you were saying, it's tricky to get right, but like when you do, it's very rewarding and looks awesome. Looks awesome. Great example of what we can do, what's available, and it's definitely something to keep an eye out for. And I fully expect, like I said, somebody to have a similar thing on a badge or an SAO.
Yeah, exactly.
Like it's definitely born for that, like that kind of flashy, but still retro kind of look. It's just great.
This video here is really just kind of an exploration of a bunch of different methods. And, that's great to see too. It's like, here I did this worked out well, and here it didn't, and have a look at the way, this bleeds through. Like, this is kind of him taking notes as he's going along and saying, this is what worked best, this is what worked less well. and the video format for this. Like, yeah, we get some pushback sometimes for running videos, and it's true. Some people are putting out YouTube videos because they're trying to make a job out of it, and that can be more or less commercial/venal. But this one's just like a guy documenting his experiments, and video is absolutely the right format for seeing LEDs blink around and comparing different diffusion aspects. So for everything, there is the right medium, is what I'm saying.
All right, this one here, I almost overlooked this one, I gotta say. I had a preconceived notion of what this was going to be, right? Because if somebody says, hey, I got some phones and I made an intercom, I say, okay, it's like, what's that? Like a 9-volt battery and a crossed over wire. I think we've kind of all seen that trick, right? Or like, I don't know, maybe they did some PBX thing, but again, we've seen that, and like I said, I almost glossed over it. But the hook here is really, it is antique telephones. Believe them, these are really antique, proper telephones. We're talking 100-plus-year-old pieces of hardware here. I mean, Matthew Dockeray that wrote this, one of the phones had like a plate in there that said like 1890 or something. Like, it's crazy that he was like using stuff still of this vintage. But these are like the proto phones, like the earliest phones. And these were phones that you would use like before there was a phone system necessarily. Like, maybe your phone system was that you ran lines between the houses in the neighborhood. Because there wasn't necessarily an infrastructure in place, these had to make their own power. So you've probably seen it in a movie or in old cartoons or something. Pick up the phone, you crank it, like a field telephone. Like that's how old school these things are. So they kind of lend themselves to making a intercom in your house, because that's sort of what they were for. They were for these kind of like ad hoc, throw some wires around, hook them up, and you don't need a switch or anything. You just crank it and the other one rings. Except, as I said, they are 100-plus years old, so they needed some love. And that's where I think this got really interesting is, he opens these two phones up, and they're very different phones, but of a similar era and technical, generation. So whereas one's more ornate and, has the mouthpieces on the phone, and you got the little handheld thing. Very, I mean, you've seen it, you've seen it in all kinds of classic movies and stuff. And the other one's a little bit more, it has like the contemporary handset and that kind of deal. They work on the same principles, and so they have their own little generators that needed to be taken apart and fixed, and there was broken parts, so some parts had to be manufactured. Put some little bits on the lathes and made cams and all kinds of there's no microcontroller in these things. A lot of it is mechanical switching and stuff, like when you put the little arm down, a thing moves over and it connects the wire. Like, everything is very mechanical and very Rube Goldberg in there, and which kind of lends itself to being able to repair it and fix it and make new parts. So I mean, that part was kind of cool. So like I said, I had the wrong impression. I thought this was going to be a lot less interesting than it turned out to be, because of just how old they are, and because it really is this kind of look at some very, very early tech that now we kind of just take for granted. And there's, whether or not you're into the phone aspect of it, I think it's cool from the repair aspect and looking at, the build quality. It's unbelievable the way things used to be, it just, hey, it's a different time, literally,
What I think's amazing about these, part of it has to do with how old they are and how primitive they are. And then you were talking about, how the switches go and how you have to crank it to get the bell to ring on the other side, and et cetera, et cetera. What's strange is how kind of continuous that became with like the next phone system. So like, this was just like what you would do if you had two houses together and you wanted to run an intercom system basically between them, right? You have to crank it. And then they're like, when we need to make a phone system, what are we going to do? Oh, we'll have these central offices and they'll do the cranking for you, right? They'll supply this voltage so that you can ring the phones. And it's weird kind of to me how the whole like on hook, off hook switching and, all of that kind of old school telephony stuff was kind of continuous with this first generation. Like, it was just expanding on this first generation, trying to kind of make it more systematized or whatever. Really weird to see this, what looks, what was kind of an ad hoc person-to-person system, then morph into the kind of huge network of interconnected telephones that we all know.
That's like the original cloud, right? Like, why crank the phone here? I can use somebody else's crank in a different building, right? Like,
exactly.
do the cranking in another building, and I will just take advantage of it. Actually, one of the kind of unrelated to the phone thing is, in the video talks about, they had these big dry cell, the old school batteries, and get them working. And he tries to keep like the old school aesthetic, and make it look vintage. And he found out that there is somebody out there making repo dry cell batteries that have modern alkalines in there, but they like scanned the label of the old school giant dry cells and printed them out, right? So they look, when they're in the device, they look like they're 100-year-old dry cells, but they just got like 2 Duracells in them. And that's a cool tip. Like if you've got some old radio or something you're trying to do, or maybe even if you're just trying to like make some kind of prop thing that looks like it's 100 years old, they really look the part. And it was a very, I always keep an eye out for the interesting hacks within the interesting hacks, right? Because those are the things that, if I may be so bold, I think that's one of the things that Hackaday is good at, right? Curating that and finding, hey, this thing's cool, but what's really cool is the thing that they use to get there. Because I think that then can be used for other projects, and so it's all about getting the cool stuff out to as many people as possible.
You may be so bold. You may. I think you can. Well, I've got 3 quick hacks this week.
Right.
I wanted to, right? I wanted to start off with El Jojo's Rememory is the amnesia hedging buddy backup you didn't know you needed. This is a hilarious write-up. The idea, on the other hand, is fairly simple. Shamir's secret sharing. Say that 5 times fast. Avi Shamir is the S in RSA cryptography, and he made the system whereby you could take a password or other secret information, split it up between 5 individuals, say, and then any 3 of them would be able to act on it. The idea is you have some secret, you're afraid of losing your password, maybe you die, maybe you end up in the hospital, maybe you just want your friends to be able to open a lockbox without your participation, but enough of them have to agree on it to do it in your absence. And that's kind of the gimmick here. This is a cool local web file based implementation of it. It's good fun if you want to look at how Shamir's secret sharing works. Joshua Stanley building a self-playing chess robot. This is kind of an introductory project, and I don't think it's his final take on it, but it's fun to see what you can do with the guts of a 3D printer that you're not using. He has little magnets on the bottom of each chess piece. He's put a Hall sensor under each square, so the Arduino that runs the show can tell where all the pieces are. It then talks to Stockfish, which is a super fancy chess engine, and plays chess for you. Moves them around with magnets. That's part of the problem he's got still, is how to get next door pieces from sticking to the piece you want to move as you slide them through. But it's really just a fun start into this kind of mechanical computer joint project that he's starting on. And I like to see it in the early phase. I imagine we'll see it again. In the comments, Rafael Collantes Belido put a link into a kind of 1900s Spanish chess computer, El Ajedrecista, which you should absolutely go look at. If you think those old turn-of-the-century phones are fun, you should check out a turn-of-the-century cams and giant capacitors and all of that chess computer. And last up, Craig Gidney, Why Haven't Quantum Computers Factored 21 Yet? Is a look from a person who actually probably knows a lot about the state of the art in quantum computing into why the proposed factoring of all the prime numbers just hasn't happened. The short version of it is that the step from finding the prime factors of 15 to those of 21 actually ends up making the circuitry involved balloon by about a factor of 100. And so if you start then thinking about, the really large primes we use for our passwords, it's going to be a lot more circuitry. And the problem at that point is getting all the error correction stuff right. And far from being a quantum skeptic, he actually says, if you want to see progress in quantum computing, what you don't want to do is look at what's the biggest numbers they're factoring. What you do want to do is look at how error correction is getting better over time and how that's going to work, because that's going to be the linchpin. He also links, I think, one of the posts in quantum computing with the best names ever, pretending to factor large numbers on a quantum computer, which is a complaint about the way a lot of the benchmark, we've just factored this number, we've just factored that number feats go, which is that they kind of build the answer into the computer design in the first place. And the author's claim, and I think that would also be Craig's claim, is that that's just cheating.
All right, well, my first quick hack is admittedly the most not hack in quite some time, but I thought it was interesting anyway. This is gaming on an Arduino Uno Q in Linux. The Arduino Uno Q, as you may know, is a Linux board, not unlike the Raspberry Pi. They're even, I think, pretty similar in price, and you can play games on it. End of hack, ultimately. But I thought this was interesting just to see, how far the Arduino has come as a platform, that you're now able to run a desktop Linux on it and with minimal hoop jumping, slowly play some old games on it. Next up is Scanning Table for the Professional Maker. This is a really slick turntable that you can make yourself by Chris Borge. The inspiration here was Chris had a 3D scanner that was great for 3D scanning, but the little turntable he was using with it kind of left things to be desired. So he made a quintessential maker's version of the turntable with all the features that he was looking for, including a special pattern on the top that he's kind of come up with that different tools and stuff can dock into. It is phenomenally overbuilt. Definitely the kind of thing that you would hold on to for a while. But fair warning, you need a massive 3D printer to pull it off. Chris said he uses pretty much the entire bed of Prusa XL to pull it off. And if you're trying to replicate this one, you'd have to break the design into quadrants or something to make it happen on a more reasonable machine. And then last is making a hidden door status sensor. This is an attempt to make smart door sensors less bad. Dylan Stock said, his experience with these was there were some ones on the market that were cheap and reliable and fairly ugly, and there were expensive, not reliable ones that integrated into the door frame, and it occurred to him that he could combine both of these products into one, and he ended up coming up with a 3D printed enclosure that lets you put the cheap and reliable hardware inside the door frame. You still have to buy the sensors in question, but apparently they're pretty easily found on AliExpress and the usual outlets, and he's released a 3D printed file, so if you want to outfit all your doors with in-frame sensors for reasons unknown, frankly, this is definitely a product to check out.
All right, well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week, I got Maya Pasha's How Industrial Robot Safety Was Written in Blood. And this is an interesting article because, I don't know, if you've played around with small hobby robots, like I have mostly, you don't think about industrial robots being the absolute disasters for the people who work around them that they are. This is kind of a walkthrough of 3 or 4 case studies of early human industrial robot interactions that went wrong, and then what the rules are that kind of came out from them. And I think what's particularly terrifying here is that a lot of these are cases where they'd obviously taken security precautions, but then the people working with the robots had kind of bypassed them. And so when you have a device that's meant to bend inch-thick sheet metal, it's pretty obvious that you don't want to come into contact with this thing, right? You don't want to be bent like that. It's fun because she talks about the kind of earliest generations of these where times were simpler, computers were dumber, and there was no real feedback at all. And, the robot arm would go here, and if you were in the way, then, bad day for you. And then how this kind of led to put the robot in a box where nobody can get into it safety culture. And then, of course, people defeat the box. And then so you have to have, a box with interlocks. And then but because people need to legitimately service it, you can then have, a key lockout mechanism to keep other people from firing up the robot while you're in there fixing it. But if you need to move it around, you need to take these precautions, et cetera, et cetera. It's keeping people safe, not just from the hazards that the industrial robots provide, but then keeping the people also safe from themselves defeating the safeguards you have to keep them safe from the robots is the tricky part. And there's some great examples here of, I don't know, what am I going to say? It's basically robots in cages to keep the people out. There's also a great bunch of comments here, and we can go through that in a minute.
Like Maya makes this point early on, and I guess I never really thought about it. I can't say I've spent much time with factory robots that
Right.
it was part of my daily thought process. But I mean, we call them robots, but that might be a little bit of a that sort of conjures up a certain level of intelligence or something, maybe.
Right.
But they are really just arms, and in most cases, pre-programmed movements that were set in stone, when the assembly line was put together and before the people probably were even hired, you know what I mean? And it's going to do what it's going to do,
Yep.
And if you're in the way, they're made for speed and for, efficiency of movement. And we're not, especially back in the early days, the idea of like, oh, let me have some kind of computer vision to look around, like, forget about it. It wasn't even part of the equation. Like, it moves from A to B fast and with incredible strength, and you do not want to be in that area. Like she said, written in blood is unfortunately very apt, and I thought it was morbidly interesting. The examples that she gave. It was kind of unfortunate that there were so many examples, frankly.
Yeah.
Because she kind of lists them off, and to be fair, it does seem like most of them involve some kind of disabling of safety protocols. But still,
Yeah.
it's a terrible way to go, and we can do better.
The examples that kind of predate the safety protocols, yeah, we can absolutely do better. And then the ones where they have safety protocols, but then people can sneak around them when it's convenient for them. That temptation's always going to be there. And who among us doesn't know it, right? So the comments here are absolutely fantastic. The comments are full of people who've worked around industrial robots and or other machines professionally. A lot of the comments that resonated with me are kind of more about the safety culture at the site, how it's important that everybody kind of adheres to these rules and takes them seriously. Because if you're in a place where people are like, I just defeat the safety interlock all the time when I need to do this, you might think that that's an okay thing to do, especially if you're new there. You don't really think about what could happen on the other side. And so there's kind of a consensus, at least among the Hackaday contributors, that this kind of workplace safety ethos is almost as important as the interlocks themselves or whatever. And I think that's kind of an interesting take.
Especially since you can, maybe you got away with it.
Yeah. You get away with it every
10
time.
times. You got away with, I turned this thing off, and I'm just going to reach in there real quick and do the thing. And maybe you've done it, it's wrong, but you've done it 50 times, and that 51st time, you won't do that again.
You get away with it every time until you don't.
You know? Right.
Yeah, and that's why these real systems are necessary, because it is so tempting, like, to take the shortcuts or whatever. Or being careless. I mean, sometimes it's just not thinking. And so if the system's designed so that you don't have to think, that's a good thing. I had a guy working on our house's electrical, and he disconnected the house from the mains, from the city's mains. And our house, and I think most of them here in Europe, are designed with these kind of big copper bus bars between the house side and the city side of the electric grid. And if you're going to work on the breakers, you go outside and you pull these bus bars out and you put them in your pocket. Because then there's no way anyone, even some evildoer, there's no way anyone can re-electrify the house if you've got the part that connects it to the city in your back pocket. That's one of those classic lockout cases, but was just looking at that this weekend. Maya brought up the U.S. Chemical Safety Board, which is a federal government bureaucracy that looks at chemical accidents and tries to make sure they don't happen again. They've got a marvelous YouTube channel. The presentation style is maybe a little bit dry, but these are terrifying industrial accidents, so, it's not going to be funny, but they're incredibly instructive and well put together and etc. If there were any way to give like an Emmy award to best chemical safety videos, this is your tax dollars at work, and it is so good. Go give the U.S. Chemical Safety Board videos a check. And if you're into something kind of a little kitschier, definitely toss Shake Hands with Danger into your web search of choice.
There's the weekend watch list sorted for anyone
dude.
listening. Looking for a new movie to watch this weekend.
Looking for a movie about industrial safety?
yeah, gather the kids, get the popcorn together. Well, my pick this week comes from Jenny List, and man, this is really one that hits close to home. Is that ancient reel of PLA any good? And I have some ancient filament that has been laying around, as I imagine a lot of 3D printing enthusiasts do. And, is it still good, right? I mean, if you got some roll that's been sitting around for, and we're not talking weeks or months, we're talking years here. In this case, Jenny says a decade-old roll, over a decade, perhaps a mysterious amount of time, in fact, roll of PLA from a local hackerspace. And the question came, like, can you still use it? I mean, it looks like filament, It's not like getting leftovers from the refrigerator, passes the smell test, so it's safe to use. And Jenny does some really cool, independent, original kind of experiments here, and I dig it. The first test is, that's the easy one. Can you print with it? And loads up the Benchy on the printer, and lo and behold, a little boat comes out. A decent one, not perfect. There are a couple weird little issues that kind of hint at something not quite right, but
suspicious.
Yeah, it's suspicious, but it extruded, right? It extruded. It looks like a boat. I've seen worse benchies on machines that I was using than what came out of this one, right? Especially if you've been in the game for a while, this would have been a high praise back in the day if you cranked this thing out. But there is some weird little foldy bits and little mushiness, and okay, fine. But what Jenny really noticed was that the cabin, or the roof of the cabin, what have you, came off very easily. The interlayer adhesion was clearly not where it needed to be. You shouldn't be able to just pull the roof off your Benchy. Just FYI, if you're curious, it should stay in one piece for most of the time. Seeing that's where the problem was, she went on and with some really cool experiments and, designed like this rectangular tube and kind of cantilevered that out over the desk and just started hanging weights off of these printed tubes. And found, sure enough, the old PLA one broke, she says, at 1.3 kilograms hanging off the side of it. And the new proper PLA, she just gave up. She says she was up to a 3 kilogram piece of, looks like train rail. I don't know where you get that. Like, let me just grab my piece of railway real quick. But it wouldn't break on that, and she was worried about putting a hole in the floor if anything bigger actually popped, right? So she just said, okay, like, it's at least
good enough.
We know that it's fine for any kind of reasonable use, She got her point across for that matter. All right, well, why? And she does mention, too, in there that it's not like this was crappy filament that just happened to be sitting around for 10 years. When it was new, she used it and it was fine, right? So it's somehow degraded in that time frame. And, Jenny does say, hey, I'm not a chemist here, but this is just kind of my theory. And I'd be interested to see, what others say about it. But we know that the filaments are not pure material in most cases. They're some kind of a blend, and PLA is no exception. They put stuff in there to make it print easier. Her theory is that those additives have kind of like off-gassed in the last decade, and what's left behind is ironically a purer product than what it was originally, but to the detriment of its printability, And hey, that's as good a theory as any, frankly, because I don't know why it would change in that kind of material sense, all things considered equal. So the answer isn't here necessarily, but also I don't know that it really needs an answer so much as it's confirmed that if you have old PLA sitting around long enough, it probably should not be used for any mission critical kind of things. You could still use it, certainly, and if you're just printing out little toys and trinkets and stuff, it might not even be a big deal, but you should not expect it to still have the same mechanical properties as it did back then. Of course, the real answer is just print more, so you don't have your filament laying around for 10 years. But if that's not an option, then this is a good thing to keep in the back of your mind.
Yeah, who are these people who have this problem with 10-year-old filament? Man.
Yeah, I can't say I have 10-year-old. I mean, I have some old filament, but certainly not 10-year-old filament.
No, in a hacker space, I could totally see it. There's a roll lying around somewhere in the back, and it's just been sitting there. I could buy it.
Yeah, some people do mention, looking through the comments, they say that it could be some kind of moisture effect got into it.
Yeah, she thought it wasn't because it didn't bubble, it didn't string,
right.
Like it didn't have a lot of the issues that moisture usually shows. But I guess if you really wanted to rule it out, you put it in a dry box for a while and you see how it prints then, right?
Yeah, that would be a very interesting.
So she could do that. Yeah, she could do that next.
Right. Yeah,
Jenny's continuing material science of
continuing research.
Crappy old PLA material science project here. But
because my thing is, I've seen, and I'm sure you've seen this is the PLA gets brittle for sure.
Yeah.
If it's exposed, if I have the roll on top of the printer and it's in the extruder, a lot of times it'll break. It'll just snap with that exposed piece of filament.
It's like bending uncooked spaghetti.
Yeah.
When it gets really bad, it just goes snap.
So I've actually had, not where the memories are flooding back. I've had some old rolls of filament where, like, I open the bag and, I always keep them in their bags, right? Try to push the air out. The bag was just full of all these tiny little broken off pieces of PLA, and like the continuity of the roll was suspect. So I was like, forget about it, because it broke off into these little, like inch long sections,
little shards.
Yeah, that's gone. At that point, it's like, all right, forget about it, because so I've definitely seen that happen. But again, she was saying that this looked fine, and she didn't actually mention anything about that particular problem. So this is a new failure mode for rolls of plastic. You would think there wouldn't be so many failure modes for rolls of plastic, but here we are.
And I don't know if it's off-gassing or what, but I absolutely know that old plastic gets brittle. If you buy something that's manufactured plastic, it tends to get brittler over time. And I don't know where the plasticizers go, but they do seem to be less plastic. And would it surprise me if that prevented the layers from sticking together super well to each other? No, it probably wouldn't. So, I do also not a polymer chemist, but I totally buy Jenny's reasoning on this one.
Now, someone also does point out, and I think we got to look at all possible answers, right?
Aliens.
Someone does say that, the tolerances on a 10-year-old roll of filament could be less than modern ones. And if you have, she's using a Prusa Mini, so it's a very modern machine. So it could be an issue where you're taking filament from a more ramshackle era of 3D printing and putting it into a machine that expects a higher caliber of feed material. That would, if it was thinner, that would certainly lead to under extrusion, right? Because the extrusion multiplier would be set for a proper 1.75, whatever.
Or set for the thick parts, and then when you hit a thin part, it under extrudes and it comes loose.
So that's
fair.
That could
fair.
be, and again, that's something take the calipers out there and spot check it. That's something that we should see if she wants to do this. I think it'd be cool to take a lot of the theories that are coming up from the comments and just do the further experiments in insofar the ones that are possible, right? So
Yeah, totally.
drying it out for sure, measuring it. I think that would be pretty cool. I mean, the real test would be, can you find a 10-year-old 3D printer to run it through and be like, that's the rub, right? You needed
it needs
proper
the sweet
error
spot.
machine. Yeah,
Exactly.
Right? It's got to have a contemporary machine to run it.
Yeah. Well, if she had some 3mm filament, I got my old school triangle frame Prusa 2 sitting there right in the back.
Go.
I'm ready to go with that one. Once I say 3mm filament, I probably have some ABS that's at least 12 years old, maybe older still. You don't want to use that. For a million reasons. You don't want to use 3mm filament. You don't want to use sketchy old ABS. You probably don't want to use ABS at all. Yeah.
I actually just got rid of it, and now I feel like I should have kept it around. I had a roll of filament that must have at least been that old, because somebody gave it to me back in like the wooden printer bot days,
Right.
So it's older. It's got to be older than 10 years old. And I forget the name of it, but it was a filament that was at least in part made from algae. And it was some, like this sustainable. PLA is pretty sustainable, but you know what I mean. It was marketed as this. Oh, it's derived from algae and yada yada yada. And the guy gave it to me. He's like, yeah, I thought you might want to check this out, because the only problem when you print it, it stinks like fish. And I was like, okay, cool, thanks. And I never opened it. And it sat, around the house for, I think just like last year, I might have finally tossed it. Because I was like, who wants to, print with something that stinks like fish? Plus, it was crazy money at the time. I remember it was like $70 a roll or something preposterous.
Oh, my God.
Because it was derived from algae, and there was all kinds of what have yous they had to do. Talk about weird value proposition. Like, not only is it very expensive, but it will stink when you use it. Like, how many can I put you down for? Like,
all right. Sounds good to me. Well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. To find the links, head on over to hackaday.com/podcast, and to contribute your own links for the future, tips@hackaday.com. And until next week,
keep on hacking. And he was like, is that going to be a problem? I was like, yeah, yeah, that will kind of be
looking like a fence post turtle. Hello and welcome to the Hackaday Podcast.
I like how the file name is never the same twice. It always gives me, is it date first or the hyphens?
Try to keep it exciting.
That is phenomenal. Wow.
I like to lead off with a banger. Let's see. Where am I going to go?
Strangely enough, I'll go with that one. We
are good with that one.